This question is from GATE 2015 Mechanical Engineering paper, Set 3, question number 47. The torque in Newton meter exerted on the crankshaft of a two-stroke engine can be described as T is equal to 10,000 plus 1000 into sine 2 theta minus 1200 into cos 2 theta, where theta is the crank angle as measured from inner dead center position. Assuming the resisting torque to be constant, the power in kilowatt developed by the engine at 100 rpm revolutions per minute is dash. Let's write the given information here. So first the expression for torque is given in terms of theta. T is equal to 10,000 plus 1000 sine 2 theta minus 1200 cos 2 theta. Next thing, they have mentioned a very important information that resisting torque is constant. We have to find out the power developed by this engine if RPM of the engine N is 100. Let's see how this will be found out. Torque is given to be a function of theta here. So as theta changes, torque will change. But it is given that resistive torque is constant. And that is why we can find one such value of torque which will be the constant value regardless of theta. And that value can be found out as the mean value. So because it's a two-stroke engine, the mean torque, which will be equal to the resistive torque and which is constant, can be found out as 1 by pi integration of the function of torque or the expression of torque from 0 to pi, because theta varies from 0 to pi for a two-stroke engine with respect to theta, of course. Therefore, by putting this expression of t here, we get 1 by pi. We'll directly take the integration of t. So the first term is 10,000. 10,000 is a constant. Its integration will be 10,000 theta. Again, 1000 remains same. Integration of sine 2 theta will be cos 2 theta by 2 will be minus cos 2 theta by 2. So this term becomes minus 1000 cos 2 theta by 2. And the last term is minus 1200 cos 2 theta. Integration of cos theta is sine. So this becomes minus 1200 sine 2 theta by 2 from 0 to pi. Let's put the limits here. So in the next step, we'll get T mean as 1 by pi. 10,000 into pi minus 10,000 into 0. So in all, we get 10,000 pi as the first term. Then for the second term, we have minus of 1000 cos 2 pi. Cos 2 pi is 1 and cos 0 is also 1. Therefore, the second term in bracket we will get 1 minus 1, which will be 0, and 500 into 0 gives us 0. So second term becomes 0 here. Let's look at the third term. Third term anyway, sine 2 pi is again 0, sine 0 is also 0. So third term also becomes 0. Therefore, torque value that we get is 10,000 pi by pi, that is 10,000. Unit of torque in the question itself is given as Newton meter. Next thing, relation between power and torque. Because we need to find out the power, we have power is equal to torque into angular velocity of shaft. Angular velocity can be written in terms of RPM as 2 pi n by 60 into t. Let's put the values and we have 2 pi into n is given to be 100 into t is found out to be 10,000 Newton meter divided by 60. So we get the power here as 104,719 watt. This can be converted to kilowatt by dividing by 1000. So 104.719 kilowatt is the value of power that we get. Let's fill in the answer. Power developed by engine is 104.719 kilowatt. To learn more about power and torque developed by shaft, you can refer to the NPTEL video, lecture 10, Power and Torque to Accelerate, from the course Fundamentals of Electric Vehicles. This course is by Professor Ashok Jhunjhunwala. He is from Department of Technology and Economics in IIT Madras. I hope the solution will help you clear your doubt. Thank you.